All right, hello, welcome back to another Math 5 video. In this video, I am just going to go over the problems on worksheet number 5, which is an introduction to trigonometry. I do have a longer video that goes in depth into how to do these problems. So if you would like more information, please watch that video as well. This is just going to be, a quick summary on how to do the problems on this worksheet. Okay, so let's start with problem number 1, and we're just going to go problem by problem, and I'll create a separate video for each problem. So problem number 1 asks us to draw the angle in standard position. So it even says, with the help of the unit circle, sketch the graph of each angle in standard position. The unit circle is going to be provided, and it's on the last page of this worksheet. So you can use that. Notice that 270 degrees is on the unit circle. So if we go back here, we can graph 270 degrees. If we want an angle in standard position, then that means that the initial side is here at the positive x-axis, and we rotate until we get to the angle measure that we're being asked for. So just a quick summary: 0 degrees is in the positive x on the x-axis in the positive direction. 90 degrees is in the positive y direction. 180 degrees, and then 270 degrees. And then finally, we get back to 0, which is also 360 degrees. A 360-degree angle is coterminal with, meaning it terminates in the same direction as 0 degrees. So 0 and 360 end up in the same spot. Okay, so there in green, we have 270 degrees. A positive angle is measured starting at the positive x-axis and counterclockwise. Okay, so then we go to the next problem, which is 90 degrees. We want to graph, theta equals negative 90 degrees. If positive 90 degrees is counterclockwise, then negative 90 degrees will just be clockwise rotation. So we have here at the positive x-axis is where our angle in standard position begins, and then it ends at negative 90 degrees. So this side here is called the initial side. And then the side where the angle ends or terminates is called the terminal side. Okay. And just a quick note, we're going to go over this in one of the later problems, but to find coterminal angles, you can just take your angle, like 90 degrees, and either add or subtract 360 degrees. And notice that if we add these two numbers together, we get 270 degrees. And that tells us that 270 degrees and negative 90 degrees are coterminal angles. And so notice these two angles end in the same location. So that's cool. Now, the next part here is 150 degrees. Well, we'll give some of the common angles on the unit circle. You can go to the unit circle and look at them yourself. But they are 30 degrees, 45 degrees, 60 degrees. We said this was 90. Let me label 0. If we add 30 degrees, that gives us 120 degrees. 135 degrees, and 150 degrees, and 180 degrees. Okay, so we are asked to graph 150 degrees. That begins at the positive x-axis as usual, and we will terminate at 150 degrees. So this is an angle of 150 degrees. Okay, so there is also another way that we can measure angles. and that is through using a radian, or through using radians. And so the equality that we want to know is that 360 degrees, meaning one entire revolution, 360 degrees is coterminal or equal to 2 pi radians. So this is also called an angle of 2 pi radians is one complete revolution. And so in part D, we are asked for, let me erase that. In part D, we are asked for theta equals pi radians. And so actually, if we divide both sides of this equation here by 2, then we get 180 degrees is equal to pi radians. And so drawing an angle of measure pi radians is the same as drawing an angle of 180 degrees. Okay. Now, this whole time, we could be using the unit circle. And so you'll notice that all of the angles that we've graphed so far, like 150 degrees, 270, we said was coterminal with -90. Pi radians was there as well. So all of these are on here. If you can find them on the unit circle, then you can, graph them in that way as well. See, if you want to go to pi, you just rotate that much. Okay, so that's a good aid there. I don't want to keep scrolling back and forth. So, you can print that sheet out and just have it next to you as you do some of these problems. Now, it would also be a good idea to learn how to swap between radians and degrees. So in this next example, maybe this next one won't be the best one, so I'll do it on part F. But 3 pi radians, so there's a couple of ways you can think about 3 pi radians, and that would be as 2 pi radians plus pi radians. And we said that 2 pi is one complete revolution, and then pi radians is a half, 180-degree rotation. So here's our initial side. The rotation given by 3 pi radians is going one revolution, that's 2 pi, but then, oops, we need to go further than that. We don't want just one revolution, but we want more than that. We want pi more. And so notice, hey, actually, pi radians and 3 pi radians, D and E, are coterminal. They're not the same angle, but they terminate in the same place. Okay, so 3 pi radians would be if you rotated 180 degrees and then rotated 360 degrees more. It is more rotation than just pi radians. Okay, so in part F, as I mentioned, theta here is equal to -pi/2. This is in radians. If you want to take radians to degrees, all we need to do is multiply by 180 degrees divided by pi radians. And this is actually just this equivalence relation here. If we divide both sides of this by pi, notice that we get 180 degrees divided by pi is equal to 1. And so really multiplying by 180 degrees divided by pi is like multiplying by 1, and it doesn't change the value of the angle. It just converts it from one measure to another, so from degrees to radians. Okay, so I'll do the multiplication here. These pi's will cancel. 2 goes into 180 90 times. So this is actually -90 degrees, which we've already graphed. So we'll just graph it again. Why not? I'll do it in purple. Here is our initial side. And here's our terminal side. The angle is negative, so the rotation will go clockwise. That's it there. All right, and then the last one, theta equals 7 pi/3. So this can be read a few different ways. This is 7 pi over 3 angles. And so 7 pi over 3 is 60 degrees. So this is 7 60-degree angles, which is 420 degrees. And 420 degrees, that is more than 360. So if I notice that my angle is more than 360, just like I did over here, where I added 360 degrees, here I can take my angle 420 degrees and subtract 360 degrees to get 60. And that tells me that 420 degrees is one complete rotation plus 60 degrees more. Okay, so if I wanted to graph this, my initial sign is still at the positive x-axis, one complete rotation, and then these markers indicate 30, 45, and 60 degrees. So there is 7 pi over 3. Another way that we could have determined this, if you want to get good at using radians, is 7 pi over 3 is actually 6 pi over 3 plus 1 pi over 3, right? Just split up 7 into 6 and 1. And 6 pi over 3 is actually just 2 pi, right? So that's one complete rotation plus pi over 3. So I could have done the same thing without actually switching to degrees. I know a lot of people are more comfortable with degrees, so you can do it either way. But how do we know that pi over 3 is 60 degrees? Well, we can look at the unit circle, and I've seen these angles along, for a lot of times. So I know that. But you can also just say, well, pi over 3 times, we said if you multiply by 180 divided by pi, that will give you the degree. 3 goes into 18 6 times. So we get 60 degrees. All right, so once you do these enough, you'll get very comfortable, swapping back and forth between radians and degrees. And then you can do something like 2 pi over 3. Well, that's just 2 pi over 3 angles. And pi over 3 when it was 60, so 2 60s is 120. Okay, and then you don't really even have to do the conversion. All right, so that was problem number 1. I will stop the video and then do problem number 2.